Warm welcome to everyone. In this video, I will present to you how using the Hvac FM simulator module to perform microclimate calculations inside a room using your own scheme for air supply. Up until now, in other videos, I've presented how to perform calculations here for adiabatic cooling, where the supply air temperature was very closely related to the wet bulb temperature. How to perform calculations using purge ventilation, where the supply air temperature was simply equal to the outdoor air temperature, and how to perform calculations using automatic selection of supply air temperature and humidity to achieve certain set parameters, where the program itself determined what specific temperatures were required to achieve the air parameters that we had set and desired for the interior of the room. Now we find ourselves in a situation where it is us who define what the temperature of the supply air should be, along with its humidity, and then as a direct result we simply observe what conditions ultimately establish themselves within the room. This is helpful if we are testing any existing ventilation systems, or if we simply want to check how the air parameters will develop inside the room, should we decide to inject or supply air with specific parameters that we have defined.
I'll just go ahead and open up an existing file
regarding geometry, and now, as I've previously mentioned in other videos, I won't be describing how to input all of this data, because for that I encourage you to watch the rather long and I must admit quite boring video concerning the complete operation of this particular program. However, you really need to step away to understand how to navigate smoothly within it. I'll just quickly mention that we enter data concerning the room's geometry, air infiltration, and the room's equipment. We then select the calculation mode, so these calculations will be done based on our set supply air temperature and relative humidity. We enter data for the partitions. I'll just add regarding the geometry itself that as we can see in the program, we de facto enter 4 partitions: north, south, east, west. However, we can of course have a room with a more complex geometry, for example, like this. In such a situation, we need to make some simplification of this geometry. I'll show you how to do it. So if we have something like this, it's easy to see that this type of room here consists of this north wall and this north wall and this south wall and this south wall, this east one, this east one, this east one, and this west one. So de facto you can simplify it in such a way that this geometry, it looks like this, right? If we shift all the walls belonging to a specific azimuth, we obtain a substitute geometry for this room in the form of a cuboid, which is identical to what needs to be entered into the program. We also sum the window areas. We also sum the wall surfaces on each side and simply input these data here into the program concerning the individual surfaces. However, we naturally choose here the country and the city that we are interested in, the date range within which we'll perform calculations. And what's very important, we either enter or input data concerning our very own temporal variables. And as I've previously stated, here we now possess the capability of personally defining the ventilation airflow rate and also the temperature and relative humidity levels. And then we carefully observe the precise impact this will have on the room. And here we can input, for example, that we will have a temperature of 20 degrees and we will be blowing in 60% humidity. Then we confirm. And we will be observing how this will affect our room here. Here we will also narrow the date range because let's say I'm only interested in just one or a few days of the year for these calculations. Let's say I'd like to perform calculations for climatic data from July 1st to, for example, July 5th. Here the program will automatically shorten these durations for us and also propose a new time step, so we can then run the calculations. And we can immediately see how the temperature inside the room will be changing for us. So this temperature will be oscillating within a range starting from here, 19.85 degrees up to a maximum of 24.3 degrees Celsius. If we are blowing air into that space at plus 20 degrees Celsius, analogously, we then obtain a graph that is related to the relative humidity. Here, as you can observe, we are introducing air at a consistent humidity level of 60%. However, the humidity within the room itself will, in this particular instance, fluctuate between values ranging from 59% down to approximately, if I'm reading this correctly, 48%. Okay, absolute humidity in a similar way. Here too, it is changing for us with this thick red line in the room, the absolute moisture content in the room. And so here, how does the cooling capacity change that is delivered by the system, and also the water balance. How does it change when water is being supplied into the room and when it is being removed from it? Anything that is above zero signifies the dehumidification of the air within the room. Everything that is positioned above is for the humidification of the air. Right, and it is in this very place that we are able to carry out various kinds of modifications. If we're not interested in, let's call it any specific climate data, but we'd like to perform calculations for our own climate profile, then we select a profile. Well, because a situation might arise where, due to technological or any other reasons, some weather anomalies occur during the season, we would like to change this so we can create, for example, our own climate profile. We can then save it here and use it in other projects for calculations. I've already gone ahead and created it here, and it can be said that we have such maximum parameters on the external side, plus 35 degrees, with some external relative humidity also imposed. And in such a situation, we can also proceed with our calculations. Yes, and that's generally everything I wanted to present in this video, so I sincerely thank you for your attention. I encourage you to use the program. Thank you. Until next time. Bye.